Hi everyone, notes 5.4 are on interior and exterior angles of polygons. And just a reminder of what we discovered in class, if you take a look right here in our triangle, just a reminder that the angles in a triangle add up to 180. So we know that these three angles should add up to 180. So I will use S for the sum of the interior angles. So here, when n equals 3, and I'll use n for the number of sides. So when n equals 3, the sum of the interior angles is 180 degrees. In this one, n equals 4 because there are 4 sides, 1, 2, 3, 4. And if I were to choose one point and draw a diagonal, and if you notice, I get one triangle on top and another triangle on the bottom. So here I have two triangles. So the sum of my angles would be equal to 180 times 2, which is 360 degrees, which we know is true for a quadrilateral. In this one, we have 1, 2, 3, 4, 5 sides. So here n equals 5. And if I choose any point and draw diagonals to the other points in my polygon here, this is specifically called a pentagon. I have 1, 2, 3 triangles. So because I have 3 triangles, the sum of the angles is equal to 180 times 3, which is 540 degrees. Okay, and lastly, in this one right here, we have 1, 2, 3, 4, 5, 6 sides. So here, n equals 6. And so when I draw in the diagonals, I end up getting 1, 2, 3, 4 triangles. So the sum of the angles is equal to 180 times 4. Why am I always multiplying by 180? Because the angles in a triangle add up to 180. So here in a six-sided figure, the angles will always add up to 720 degrees. So if I were to summarize this information in a chart, where n is the number of sides, this is the number of triangles, and s is the sum of our angles. When I have 3 sides, there's 1 triangle. When I have 4 sides, there are 2 triangles. When I have 5 sides, there are 3 triangles. And when I had 6 sides, there were 4 triangles. So if you notice, every single one of these numbers is 2 less than the numbers that we have here. So if this is n sides, then this would be n minus 2. Now, to figure out what the angles add up to in our polygons, here I would do 180 times 1 because there is one triangle. For this one right here, I did 180 times 2 because there were 2 triangles. For this one right here, I did 180 times 3 because there are 3 triangles. Here, I did 180 times 4 because there are 4 triangles. So if there are n minus 2 triangles, then I would do 180 times n minus 2. So therefore, I can say that the sum of the interior angles of a polygon with n sides would be equal to s equals 180 times n minus 2, and that will always be true. And so now, just a heads up, a regular polygon is a polygon in which all the sides are equal to each other. And because the sides are equal to each other, the angles are equal to each other. So to figure out how big each angle is, like let's say, for example, right here, this was a regular pentagon. I know all the angles add up to 540 here. So to figure out one angle, I just have to divide 540 by 5. And when I do that, I get 108 degrees. So here, all I have to do is take the sum, this s right here, and divide it by however many sides there are, or however many angles there are. And then lastly, the sum of the exterior angles of a polygon will always be 360. No matter how many sides it has, it will always be 360. And this is something we discussed when we did our Desmos activity. So in question number 1, it says find the sum of the measures of the interior angles of a heptagon. So in a heptagon, our n value is equal to 7. A heptagon is a 7-sided figure. So let's use the formula to find the sum of the interior angles, which is what we want to do here. So 180 times n minus 2. But if n is equal to 7, then I would plug in 7 here. And sorry, I'm running out of room here, so I'll bring this up here. So the next thing I need to do are my brackets. So 7 minus 2 is 5. And then when I multiply 180 by 5, I get my final answer, which is 900 degrees. So therefore, the angles in a heptagon will always add up to 900 degrees. All right, in our next example, it says find the measure of angle A in the diagram. So the first thing I need to do is I have to find S. I have to find how much the angles will all add up to. And in order to be able to do that, I have to find out how many angles there are or how many sides there are. So here I have 1, 2, 3, 4, 5, 6 sides. And I can also see that I have 1, 2, 3, 4, 5, 6 angles. So I don't know why I wrote n equals 2 here, because that's not true. It's n equals 6. So this figure has 6 sides and 6 angles. So to find S, I would do 180 times n minus 2, but instead of n, I would replace that n with that 6. Let's go up here since I'm running out of room. So S would equal, so now 6 minus 2 here gives me 4, so I would have 180 times 4. And when I multiply 180 by 4, I end up getting 720 degrees. So I know the angles should all add up to 720. Now, I can use S to find the missing angle. I know that all of these should add up to 720. So I'm going to add up all of these angles right here. So 105 plus 142 plus 88 plus 136 plus another 136. When I add up all of those numbers together, I get 607. Now, I know that the angles will all add up to 720, so I can take 720 and subtract the angles I do know from that 720 to find out my missing angle, which would be 113 degrees. So therefore, the measure of angle A equals 113 degrees. All right, we're going to define what a regular polygon is again. And it's a polygon with all congruent or equal sides and angles. So in question 4, it says find the measure of one interior angle. So this time I just want to know one interior angle of a regular dodecagon, which means all the sides will be congruent and all the angles will be congruent. So the first thing I have to do is find S. I want to find out what will the angles all add up to. So I will do 180 times n minus 2, and I know that the n right here has to be 12 because a dodecagon is 12 sides. So here I can say S equals 180 times 12 minus 2. So let's go ahead and figure out what this will give me. Well, 12 minus 2 is equal to 10, so I can say here S equals 180 times 10. And if I were to multiply those together, I would get 1,800 degrees. So I know that the angles in a dodecagon will add up to 180 degrees. But I want to find out just one angle. And since all the angles are congruent to each other, I can divide the total number of the angles, the total measurement of all the angles together by however many angles there are because it will be split evenly. So I can take this 1800, divide that by 12 because 12 is what n is right here. And when I divide those two numbers here, I get 120 degrees. So therefore, one interior angle in a dodecagon is 120 degrees. And by the way, that dodecagon has to be regular, so I forgot to add that in to my therefore statement. It's really important we add that in. All right, in this question right here, number 5, find the measure of one exterior angle of a regular dodecagon. Well, what do the exterior angles add up to, right? What's the total of what our exterior angles are? It's 360. No matter what, the exterior angles of any shape, no matter how many sides it is always going to be, they're always going to add up to 360. So step one, I want to find the total, but it's already given to me. I already know it's 360. I don't have to do any calculations for that for exterior angles. But now I can divide that 360 by n, which again is still this 12 right here. So here I can just take 360, divide that by 12, and I end up getting 36 degrees. So therefore, one exterior angle of a regular dodecagon is 36 degrees. All right, cool. So in question number 5, it asks us to find the measure of angle G. So it's this angle right here that I want to find out. So the first thing I need to know is, what do my angles add up to? And to do that, I would have to use the formula S equals 180 times n minus 2, where n in this example would have to be equal to 1, 2, 3, 4, 5, 6, 7. So here I know n equals 7. I also know it's 7 because I have 1, 2, 3, 4, 5, 6, and then my missing angle is angle number 7. Now notice I circled the right angle. Even though there's no number there, it's still an angle. We still have to use that. So here I would say S equals 180, and then instead of n, I would replace it with 7. So I would do 7 minus 2. And I know that 7 minus 2 is equal to 5. And so when I multiply those two numbers, I get 900 degrees. So I know altogether my angles will add up to 900 degrees. Now I need to use that to find the missing angle. So to figure that out, I need to add up all the angles that I do know. So I know this 140, I have another 140, I have a 90, I have this 130 right here, I have 150, and I have 120. So when I add all of these numbers together, I end up getting 770 degrees. Now, since the angles all together add up to this 900 degrees, I can take that 900 and subtract 770 from it. And when I do that, I get 130 degrees. So therefore, the measure of angle G is 130 degrees. All right, people, last question. Find the measure of angle X. And if you notice all of these angles out here, and sorry, that should say angle 1. If you notice all the angles out here are all exterior angles. Well, I need to think, what is the sum of my exterior angles? Or what should my exterior angles add up to? And that answer is always going to be 360. No matter what, it will always add up to 360. And then I need to use 360 to find angle 1. Well, how do I do that? First thing I want to do is add up all the angles that I do know. So I do know this 117, this 57, this 59, and this 85. What do I get when I add those all together? 318 degrees. So I know that they'll all add up to 360, so all I have to do is take my total, which is 360, subtract that 318, and I end up getting 42 degrees. So therefore, the measure of angle 1 is equal to 42 degrees. And I'm done with that question. And that's it for this video. If you have any questions, let me know. Otherwise, I'll see you in class. Bye.